All right, 7.4, this is identities, and so now we're trying to make this look like this. Cosecant is 1 over the sine minus cotangent is cosine u over sine of u. They have a common denominator. So this would be 1 minus cosine u over sine of u. Well, that's not looking so good right now, but let's now multiply the numerator and denominator by the, we need a 1 plus cosine u in the denominator, so I'm going to multiply by 1 plus cosine u over 1 plus cosine u. So this equaled this, which equals this times this is going to be 1 times 1 is going to be 1 plus cosine u minus cosine u minus cosine squared u. And the middle term is going to cancel out of that. And this is going to be sine u times 1 plus cosine u. And I don't want to multiply the sine in because I want that to stay. Now 1 minus sine, cosine squared is sine squared u by the Pythagorean theorem over sine u times 1 plus cosine u. One of these signs cancel, and I have sine u over 1 plus cosine u. 45. Okay, someone said cleverly the tangent times cotangent would be, they would just cancel, so they just said multiply everything by cotangent v over cotangent v. Alright, so if you take cotangent v times 1, you get cotangent v. If you take cotangent v times tangent v, that's cosine over sine times sine over cosine, and they're all going to cancel, and we're just going to get plus 1. And cotangent v times 1 is 1, and cotangent v times tangent is, that's going to be cotangent v when you take it times 1. And cotangent times tangent is going to be 1, so it's going to be minus 1, and we're done. 35. It says square this. So you can take it times this sine of theta plus cosine theta, and we're going to get sine squared theta plus sine cosine plus another sine cosine, that's 2 of them, plus cosine squared. And then we square this and we're going to get the same stuff, except it's going to be sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. And so we have sine squared theta plus cosine squared theta, that's 1, and then we got sine squared plus cosine squared, that's another 1, so that's 1 plus 1, and then these cancel out, so they get 2. That was 35. I did those out of order. Here's 50. And secant is 1 over cosine. So I'm just going to multiply the numerator by 1 over cosine theta and the denominator by 1 over cosine theta. 1 over cosine times cosine is 1. 1 over cosine times 1 is 1 over cosine, which is secant theta. This will be 1, and this will be minus secant theta. Done. Next one. Okay, we want tangents. Tangents are sines over cosines, and we need a tangent squared, so we better divide by cosine squared. So I'm going to multiply the numerator by 1 over cosine squared theta, and the denominator by 1 over cosine squared theta. So this times this, one of the cosines are going to cancel, and I'm going to get sine of theta over cosine theta over 1 over cosine squared times cosine squared is going to be 1 minus, this will be sine squared theta over cosine squared theta. So we end up with tangent of theta, because that's sine over cosine, and then 1 minus tangent squared theta. Next one. This one's a little trickier. So let's just switch this to cosine over sine. So we got 1 minus cosine squared theta over sine squared theta over 1 plus cosine squared theta over sine squared theta. Making common denominator, making these be sine squared theta over sine squared theta, that's 1, and then this one be sine squared theta over sine squared theta. So we get sine squared minus cosine squared over sine squared. Oh no, I forgot this other plus 2 cosine squared theta. Should have that in there. And over 1 a sine squared plus cosine squared, which is 1 over sine squared theta. And since these are both over sine squared, those will cancel by multiplying by 1 over sine. But then we also have 1 over sine squared over 1. Sine squared over 1, and top numerator and denominator will cancel those. But we still have plus 2 cosine squared theta. So we have sine squared minus cosine squared plus 2 cosine squared. So the 2 cosine squareds will go with a minus cosine squared, and we'll have sine squared theta plus cosine squared theta, which is 1. Didn't leave myself enough space for that one, but I got it, I think. Hopefully you got it now. This one. Okay, we could just change everything to sines and cosines, but secant squared minus tangent squared. Well, we know from the Pythagorean theorem on tragus, sine squared theta plus cosine squared theta equals 1, and so secant is 1 over cosine, so we're going to divide everything by cosine squared theta, or cosine squared v. And so we get sine squared is tangent squared, I'm changing the thetas to v, plus 1 equals secant squared v. So I can put tangent squared theta plus 1 right here. So I'll have tangent squared v plus 1 for the secant squared minus tangent squared plus tangent v over secant v. And the tangent squareds cancel. Secant is 1 over cosine, so now I'm going to go to sines and cosines. So I have 1 minus sine v over cosine v over secant, which is 1 over cosine v. So I'm going to multiply the numerator by cosine v and the denominator by cosine v. Those will cancel. Cosine v times 1 is cosine v, and cosine v times, oh, tangent, this is plus here. Cosine V times that would be plus cosines would cancel and be sine V, which is what we were supposed to come up with. And now 90. This one, a little hard to see what to do on this one, but if you multiply by 1 minus cosine theta plus sine theta, kind of a conjugate of this part and the conjugate of that part, some nice stuff works out here. But there's a lot to do to get to that. So 1 times 1 is 1 times this is going to be 1 minus cosine theta plus sine theta. Cosine times that is going to be plus cosine theta minus cosine squared theta plus cosine theta sine theta. And then we have sine times all that, which is going to be sine theta minus sine theta cosine theta plus sine squared theta. And the denominator is going to be 1 times that is going to be 1 minus cosine theta plus sine theta. Cosine theta times all that is going to be plus cosine theta minus cosine squared theta plus cosine theta sine theta. And then minus sine times all that is going to be minus sine theta plus sine theta cosine theta minus sine squared theta. And what a mess. Let's see if this simplifies a little bit here. So we have 1 minus cosine squared is sine squared plus another sine squared, so that's 2 sine squared theta. We have minus cosine theta plus cosine theta. We have plus sine theta plus sine theta, so that's plus 2 sine theta. And then we have cosine theta sine theta minus cosine theta sine theta. Those cancel. And that's what we have in the numerator. Over denominator, we have 1 minus cosine squared, which is sine squared, minus sine squared. So this with this cancels that. Then we have minus cosine theta and plus cosine theta. Those cancel. We have sine theta minus sine theta. Those cancel. And then we have these 2 sine theta cosine theta. And so we can multiply the numerator and the denominator by, let's see, 1 over 2 sine theta, because I see a 2 sine theta in both of these, and 1 over 2 sine theta here, and we'll get everything cancels here except for 1 sine theta, and this will be plus 1 over here. We'd get cosine theta, and that's sine over cosine is tangent theta, and 1 over cosine is secant theta, which is what we were supposed to get. Yuck.